We're going to look now at this MapReduce environment. So the MapReduce is a programming tool that was created in order to utilize this distributed environment that I mentioned. So we will see how distributed environment looks like, in a sense that we have multiple computers that work at the same time on the same task. And this MapReduce can be used to program to tell them what to do. We will see MapReduce, and Hadoop is the platform on which it runs. So this Hadoop can provide the distributed file system that we need. And we will look at the example MapReduce algorithms. So we will look at some algorithms that this MapReduce can be used for. So the first subject is the distributed file system. So we will see what happens with that file system. It's a file system, kind of like the one you have on your laptop. However, it's not one laptop, it's maybe hundreds and thousands of them, and now we need to connect them all together to work on our huge data set. Right. So we will see how we're going to do that. We're going to create chunks and send each chunk to one of these computers somewhere. And replication, the replication is about multiplying the pieces, keeping multiple copies of them. And we will see how we're going to arrange these data on these computers like that. So what happened is, as I mentioned, Facebook and Google and other companies had to do with these huge amounts of data that cannot run on a single computer. They were thinking what to do, and they came up with this idea of we're going to use just some basic computers, like our home computers, commodity computers, and create a cluster from them. So a cluster means we will link all these everyday computers together and make them work all together. Cluster of commodity Linux nodes. The node is a machine which is part of the cluster. So these are called compute nodes, so they're going to be doing some computation. It's a commodity computer, so the node is just a regular computer. It has processor, memory, and disks, hard drives. How are they connected? They're connected with a network. Some of you have taken the networking course with me, and you already know what is gigabit Ethernet connection. Others of you don't know this, it's just a network connection. So connect computers through a network, and it can send 1 gigabit of data per second. Ethernet is the standard network, the most popular wired cable network that exists in the world, and that is the one we have here for this computer, for the instructor computer that is plugged into the university network through Ethernet. So Ethernet is just a type of local area network. So these computers are connected through a regular network. Ethernet works with a switch. What is a switch? Again, some of you already know this. It's a device that you can plug in multiple network cables into it, and it decides on which cable to send the frame or the data packet. So on the network, computers are sending packets between each other of data. See, one computer wants to take to another computer and sends a packet. The switch, Ethernet switch, links together all of the computers that want to talk to each other on the local network. Now you can have other connections here. And the switch is just a device that decides on which of these output lines to send the packet. Let's say this computer wants to talk to that computer. The switch knows the address of the sending machine and the address of the receiving machine and forwards the data frame into this output cable. That's a switch. It's different from a router because the router is a more intelligent device. It works in the next networking layer because not all the machines are directly connected to the router as they are to this switch. One computer can be here, another one in China, and the router has to calculate the path from here to China, so it has more work to do than the switch. So the router has to calculate the best routes to take to the destination. So in this case, all of our computers are within physical reachable distance from each other, so they are connected with the switch. This is the node. The node, it's a regular computer. It has a processor, main memory, and a disk or a hard drive. And like I said, we have a bunch of these computers. There could be a lot of them connected together through this switch. Earlier we said it was 1 gigabit Ethernet. Now that is the network connection is slower here and it is faster up here. So pretty much there is one main computer that has knowledge about all the other computers in this cluster, and it knows which computer to send, which computer contains which piece of data. But the overall architecture of a cluster looks like this. There is a bunch of regular computers connected through a network cable through these switches. Now, some of these computers might break, right? Because there are, we said we're going to use our everyday computer that you have at home. This computer can fail. Maybe the hard drive got corrupted, or it crashed, it was compromised, or it was hacked, or it has some other problem, and it's dead. And the computers can fail like this. So the idea is we want to do something about this failure. What are we going to do to prevent this, to handle this kind of issue? So we're going to create a special file system to use on all of these computers. So the file system, as we know, is pretty much the directory tree that you see on your laptop. You have folders, directories, and files inside of them. However, the operating system manages all these files, right? The operating system knows where each file is at. If the file is big, it has many pieces. It knows which piece of the file is on which sector of your hard drive, right? Because the hard drive is split into blocks. And it knows on which block is which part of the file. We have the same situation here. So we're going to create this file system, and when there is a big file, it might be split into blocks or pieces, and each block might be on a different place. Now on your laptop, it's going to be on a different sector on your hard drive. In this case, it might be on a different computer altogether somewhere on the network. And that's why this is called a distributed file system. So we're going to have this file system that we can place parts of the files on any of these machines anywhere in the network. And we will make it look like it's a one single file system, that you cannot tell that this piece is not on your laptop but is somewhere off the network somewhere. So it is called a distributed file system for that reason. We will make it look like a one single file system. to implement that. How are we going to implement that? So there's going to be a global file namespace. There has to be one machine that knows where all the pieces are, kind of like your operating system knows where all the pieces of your files are on the laptop. So there's going to be a global file namespace. So one machine is going to serve as this file namespace to know where all the pieces are. And so Google has its own such a file system. It's called the Google File System, GFS. There's others, Colossus, and this Hadoop Distributed File System. That is the one that we will look at, and this is the cluster cloud environment we have set up here at the university. There is also we also have now access to the Amazon Web Services, so we can use those as well. But that's pretty much like the one we have here, except that they have a lot more computers in their cluster than we do here. But it's the same thing. So we will look at the Hadoop Distributed File System. So we're gonna split these files into these pieces, what called chunks. What should be the size of this chunk? What do you think is the size of the chunk on your laptop?
Same size?
Same size? Some of you took operating systems class with me, and you probably remember that. The size of the chunk is actually smaller than that. This is much bigger than the size of the laptop, the chunk. And the reason for that is because we are going to be working with large amounts of data, and we are likely to fill up these chunks easily. Because if it is on laptop and you just create your homework file, it's not going to be this big. It might be like 1 megabyte or something like that. And if you take up, if the chunk is 64 megabytes and you save that 1 megabyte file, the rest of the 63 megabytes will be wasted. So we have to be very careful of how we assign these chunks. Depending on the application, if it's going to be for a laptop, you can make it smaller. If it's going to be for some huge clusters trying to analyze large amounts of data, we can make it bigger. So they make it around this size, 64 megabytes. Now the problem is these machines can fail, like I said, at any time. So if the parts of the file is on some machine and the machine died, what are we going to do? So we need to create some backups. So we're going to multiply each of these chunks 3 times and save it in different places. We don't want to put all of our eggs in the same basket, so we will save the chunk in several places just in case one failed. So try to keep them on different racks. So the rack is a place where we have multiple nodes. Let's say the rack might have like 6 nodes. The master node is the node which stores the metadata and the location of all the chunks. So this is that's that one computer that knows where all the chunks are, and it's called master node, and it sits on the top of that architecture that we have seen. It knows where all the pieces are on all the computers in this cluster and where are all of their copies in case one failed. What it looks like. These are racks of computer nodes. So this is a one rack. It has 1, 2, 3, 4, 5, 6, 7, 8 nodes. Oh, there are 8 computers in that rack. And let's say we have some huge data file. Each of these chunks is 64 megabytes. So this file is 1, 2, 3, 4, 5 times 64 megabytes. So we will split it into pieces, and each of the pieces will go into anywhere on these data nodes. The idea is, first piece is the yellow piece. It went once over here, and once over here. We have 3 copies of it. Same situation with the blue piece. 1 copy here, 2nd copy here, 3rd copy here. Same situation with the purple piece. 1, 2, 3, 3 copies. So 3-way replication of files, and the copy can be anywhere on a different, even on a different rack. Again, these are connected through network. This is network cables. There are other ways to do this. We could use a stable storage, which allows to reproduce the missing piece. It allows a reconstruction of a lost chunk. And if we do that, we have to replicate it less number of times. The thing is that we have no control of where it's gonna store the pieces. It could store them very far away, and if it does that, obviously networks are slow and it takes time to go through a network to obtain parts of the file compared to just taking the time from your CPU to get to your hard drive to obtain the file. That's a lot faster than getting a piece of file that's sitting off on another machine on the network somewhere.